Okay, today we're going to start a normal curve of variability notes. Okay, so why is the study of variability important? Okay, why do I need to know how spread out my data is? It allows us to distinguish between usual and unusual values. Okay, variability deals with the greater the variability, the further away each data point is from each other. The smaller the variability, the closer together your data values are. In some situations, you may want more or less variability. If you have a score on a standardized test, if you think about time bombs, okay, military uses time bombs. If a bomb is supposed to go off in a certain amount of time, you better hope it doesn't go off before then, right? So you definitely want a set variability on those. Think about medicine. Okay, if a medicine is supposed to last so many hours, it's fine for it to last longer, but you probably wouldn't want it to last shorter. And maybe some medications you don't want to last too much longer if you're thinking about surgeries and whatnot, okay? So variability always depends on the scenario and whether you want more of it or less of it. So what are our measures of variability? We could describe range, max value minus minimum value, and that's the most common one we describe in regards to variability. We could also talk about your interquartile range, your Q3 minus your Q1. And again, that would be the middle box of your box plot, okay, 50% of your data. We could talk about the deviations, each value minus the mean, that is a deviation. We could talk about a variance, and I'll give you the formula for that in a minute, which is sigma squared. And we could also talk about standard deviation, which is sigma. And again, I will give you the formula for that here in a minute. But most common, if we're going to describe variability, we're probably going to talk about range, IQR, or standard deviation. So the average of the deviation squared is called the variance. And if we're talking about the population, we're going to use sigma squared. If we're talking about just a sample, a small subset, we're going to use little s squared. And remember, PP, population, is talking about a parameter. SS, sample, is talking about a statistic. So calculation of the variance of a sample. Again, we have a big complicated formula, but don't worry, this is on your AP formula sheet that you will get for the AP test. So variance is as S squared, if we're talking about sample. Big summation, we're adding up all. We're going to take each data value, subtract it from the average, from the mean. We're going to square that, and we're going to add that up for every single data value. Then we're going to divide by n minus 1, which is our degrees of freedom, and n is always your sample size. So let me show you where this is located on your AP formula sheet, and also where your AP formula sheet actually is on your Schoology. So if you go to Schoology, right here in the yellow folder, it says formula sheet, study sheet, and random digit table, okay? So if you have a printer at home, I highly, highly recommend you printing this formula sheet, okay, getting familiar with it. This is the resource, these are the resources that you will have on the actual AP exam. Okay, so notice it gives you formulas here. Notice it only gives you formula for S. We're going to talk about here in a minute that standard deviation is simply just the square root of the variance. Okay, so they do expect you to know little s is standard deviation. If we square both sides, the square root goes away and we get variance, okay? So if you have a printer at home, print this formula sheet. Again, these are the resources that you will have on the actual AP test. What's nice is that for AP Stats, you don't have to memorize a lot of formulas. They provide them here on the formula sheet, but you do need to know where they are, how to utilize them, what the variables represent, okay? So again, if you do have a printer at home, I suggest printing this. That way you have access to it while you're working on homework and whatnot. In this chapter, we will be using the Z table that is located here. That will be in the next day's notes. So this is where you find your Z table and your chi-square table, which we will use at the very end of the year. So just be aware that that is in the yellow folder on Schoology, in case you need to access that. Reminder also, you have your random digit table here. Okay, so any homeworks that need a random digit table, that is located in this folder as well. So since we don't quite yet have textbooks, you can utilize this. Okay, so just showing you where it is located in your Schoology. So again, don't need to memorize, but make sure that you know where it is on the formula sheet, and that variance is your little s squared. Okay, just eliminate the square root. So what is degrees of freedom? Degrees of freedom is n deviations contain n-1 independent pieces of information about variability. So really all you need to know for degrees of freedom is that it is n-1. And what does n? N is your sample size. Okay, so if I have 20 data points, my degrees of freedom would be 20 minus 1, 19. If I have 100 data points, degrees of freedom would be 100 minus 1, so 99. A standard deviation is a measure of the average deviation from the mean. Okay, it is the average deviation from the mean. Think of it as kind of the average distance, each data value's average distance from the mean. The greater the standard deviation, the further apart your data values are, okay? The greater your range will be, the greater your variability will be. The smaller the standard deviation, that means the closer to the mean each data value is. So the smaller the range, or the smaller the variability. So again, here's your calculation. Again, this is the exact formula on the formula sheet. Again, notice all you have to do is take the variance s squared and square root both sides. Okay, so standard deviation is going to have square root. Think of it that way. SS, I use that letters a lot. But just make sure again that you understand where it is on the formula chart and that you know the definition. It is the average distance from the mean. So which measures of variability are resistant? And what do we mean by resistant? Resistant means they're not going to change, they're not going to affect. So that means if I add an outlier in, they're not affected, okay? And the one measure that is not affected is the IQR. Because think about it, if your interquartile range is the middle part of your box plot, if I add a very high value, the highest value, like the maximum value, or if I add a very different minimum value, is that going to affect that middle box? No, it shouldn't affect that middle box that much, right? Because it's on the whisker part, right? It's the outer part, okay? So IQR is resistant to outliers, okay? That's why we can utilize it as a sense of variability, okay? It is a middle 50%. But if we kind of have a value way higher or way lower, this won't be affected as much comparative to the mean or the median. So linear transformation rule says that when adding a constant to a random variable, the mean changes, but not the standard deviation. Okay, so if I add 100 to every data point, I'm basically, think about it in our Algebra 2 lessons, I'm doing a translation, right? I'm moving every single data point. That means the average is going to be moved by 100. So the mean will change, but I'm not changing my high minus low. If I add 100 to everything, well, my high minus to low subtracted will still be exactly the same as if I didn't add 100. Now the mean will change by exactly that amount, okay? It should be 100 greater. When multiplying a constant to a random variable, both are gonna change, okay? So if I'm multiplying by a value, that means I'm taking a percentage. If I'm increasing something by 30%, 130%, well, percent is gonna be different for every single data value, right? Okay, the smaller the value, the less I'm gonna, unit-wise, I'm actually gonna be adding to it, okay? If I'm taking a percent of a larger number, unit-wise, that number is gonna increase by a larger amount, okay? So you actually are going to have a exploratory activity as one of your assignments to hopefully better understand this. But when adding, only the mean changes. When multiplying, both are gonna change. So let's look at an example. An appliance repair shop charges a $30 service call to go to a home for a repair. It also charges $25 per hour for labor. From past history, the average length of repair is 1 hour 15 minutes or 1.25 hours. And the standard deviation, so the wiggle room, could be 20 minutes or 1/3 of an hour. So including the charge for the service call, what is the mean and standard deviation for the charges for labor? So basically, if I call this appliance repair shop, okay, on average, what can I expect to pay? based on their average fees and their average length of time of service. Well, if we look at the mean, okay, the mean means I've got to first pay $30 just for them to come to my house. And it says on average, they're going to charge $25 per hour, and normally it takes about 1.25. So we're going to take that 25 per hour and multiply it by the average 1.25 hours. And we're going to add that to the $30 it takes just for them to get to the house. So when we apply that math, we get 61.25. So on average, the cost is 61.25. Well, what's the standard deviation? Well, standard deviation, think of it kind of as wiggle room. Well, if on average, somebody's going to pay 61.25, about how much could it go above or below that value? Think of it, standard deviation is that a way. So if we look at standard deviation is the average distance from the mean. So we're going to take our hourly rate 25 times 1/3, because again, on average, the wiggle room might be 1/3 of an hour. And it could be, give or take, 8.33. Okay, so if I'm going to look at a good range of prices that I would have to pay for calling this appliance repair shop out, it could be 8.33 above 61.25 or 8.33 below 61.25. Okay, so think of standard deviation as kind of like your wiggle room. On average, what is the difference going to be from the mean? So rules for combining variables. So to find the mean for the sum or difference, all we got to do is add or subtract the two means. Okay, that is straightforward. I can directly add a mean, I can directly subtract a mean. But to find the standard deviation of the sum, we always add the variances and then take the square root. So formulas to remember, if I want to find total mean or difference of mean, I can directly add or subtract the means instead of adding and subtracting every single data value. But standard deviation, never, never, never directly add, okay? I say for combining standard deviation, think Pythagorean theorem, okay? You're gonna take big square root, you're gonna take the first standard deviation squared plus the second standard deviation squared, big square root. So think Pythagorean theorem. Notice this middle, whether you are adding standard deviations or subtracting standard deviations, you are always adding. And why that is think about it. If we're subtracting and we end up with a negative, are we going to be able to take the square root? Square root of a negative is not a real number. And if we're talking about statistics, we have to only be talking about real numbers. We're talking about real world data. So think Pythagorean theorem. So let's look at an example of this. We have a bike shop. And bikes arrive at a bike shop in boxes. Before they can be sold, they must be unpacked, assembled, and tuned. Based on past experience, the times for each setup phase are independent with the following means and standard deviations in minutes. What are the mean and standard deviation for the total bicycle setup times? Okay, so here notice it gives us the mean and the standard deviation for each part of the bike assembly. We want to find total, so the keyword is total. So if we're looking to find total mean, well, total mean means adding, and we can directly add the means, 3.5 plus 21.8 plus 12.3. But standard deviation, never, never, never directly add. Think Pythagorean theorem. Okay, so if we directly add the means, total mean will get us 37.6 and minutes. Always make sure to add in the units. Remember, we talk about the number is just the data. Statistics is applying it to what you're talking about. So what does this 37.6 represent? It represents minutes. And standard deviation, think Pythagorean theorem. Big square root, 0.7 squared plus 2.4 squared plus 2.7 squared gets us a total of 3.68 minutes. Okay, so on average, it will take me 37.6 minutes to assemble the bike. My wiggle room, it could go above or below that by 3.68 minutes.